Welcome to our session today, where we're going to look at production theory. To start with, when we're dealing with production, what is production? So production is simply a process that converts the raw materials that we have in terms of labor and capital. Labor is denoted by L, capital is denoted by K, into output, which we denote by Q. So under production, you must understand that production is epitomized by what we call isoquants. And these isoquants are downsloping curves which look like this. Isoquants are simply points at join points that offer the same output. So the principles that isoquants have are as follows. They are convex, isoquant 1, isoquant 2, isoquant 3. We know that as we go high up, the topmost isoquant offers the highest combination of labor and capital production. So again, I ask, what is an isoquant? An isoquant is a what? These are lines or graphical representation in economics that are used to depict inputs that offer the same output. These are called isoquants. So the 7 properties of isoquants include, I mentioned 1, they are convex. What other properties of isoquants should we know? They are downward sloping. They are non-intersecting, meaning they're parallel to each other. They are smooth. They are the higher isoquant offers higher output. So these are the properties of isoquants. So isoquants are very important because they help us measure efficiency. How efficient are we combining the input between labor and capital? So these are the isoquants. They depict a combination of inputs that will produce the same level of output. The term iso means equal. Quant means quantity. So isoquants give us what? An iso revenue or iso cost, or they specifically focus on the relationship between input and their outputs. And we have also tried to measure these relationships in terms of the properties. So there are several properties. I've just mentioned 7 for you to remember in the exam. So some of the properties that we must know of are as follows. Isoquants are what? Downward sloping. They're convex. They're non-intersecting. Isoquants are also continuous. They don't touch the bases. They go down. They are smooth. And an isoquant on top offers a higher, as we go to the right, offers a higher output than the one below it. So we also have what we call the marginal rate of technical substitution, which occurs at a point where the isoquant kisses the budget line. So this is what we call the optimal bundle. This optimal bundle occurs when the marginal product of labor divided by the wage is equal to marginal product of capital divided by the rent. So in production, we know that the production function is simply a function that gives us a relationship between labor and what? Capital. The cost in production is given as follows: rent for capital as wages for labor. This is what we call the optimization problem. So together, this helps us come up with what we call the Lagrangian function, which helps us optimize production, where we have our output in terms of labor and capital minus the budget constraint. Budget constraint here, we're just making everything inside there. We have capital, cost, rent for capital, minus wages for what? For labor. So this is what we call the Lagrangian function. So combined together, this is what we call constraint optimization. What is a constraint? A constraint is a limitation. We want to maximize production as much as possible. We want to produce the higher isoquant, but this will only be limited by how much the budget line we have. So at this point here, this is what we call the optimum bundle. This optimum bundle can be calculated using the Lagrangian function, or we can calculate it using what? The optimum bundle, where the marginal product of capital over the rent is equal to the marginal product of what? Of labor over the wages. So a quick recap on our calculus. If you have output as 100 L to the power 2, A to the power 4. So we're going to differentiate the Q over the L. This is called the marginal product of what? Labor. Our dummy is K4. We're going to differentiate 100 L2. What we get? 200 L. We're also going to differentiate the Q over the K. This is called the marginal product of capital, MPK. In this case, our dummy is what? L2. We're going to differentiate 100 K4. What is 100 K4? To give us 400 K what? K3. Are we together? So this is what we call a partial derivative. So let's try to differentiate. Suppose we had a function like 2LK to the power half. This can be written as 2L to the power half, K to the power half. So let's differentiate the Q over the L. This is called the marginal product of what? Of labor. Our dummy here is what? A half. So what are we going to differentiate? 2L to the power half. So half times 2 is 1. We never write 1. Half minus 1 is negative half. So this is called our marginal product of labor. The Q over the K is called the marginal product of capital. So our dummy in this case is what? L half. So we're going to just deal with the 2 and the L half. So half times 2 is 1, which we'll not write. Half minus 1 is negative half. So the K is 1 that will have a negative half there. So combined, a question may simply come to say, suppose your Q is what? 2LK half. And our cost, for instance, is maybe 80 kwacha. The rent maybe is what? 3 kwacha. The wage maybe is what? Let me put the rent maybe 10 kwacha. The wage is maybe 40 kwacha. They'll ask us, but A, write down the budget line. We remember the formula for the budget line? Cost is equal to what? Rent for capital, wage for labor. So here we have 80 is equal to what? 10K plus what? 40L. Altogether, this is our budget line. Part B, how many units to maximize what? Maximize production. So I'll teach you the easiest way of optimizing or maximizing production. We remember the optimum bundle. It occurs when the marginal product of labor over the wage should be equal to the marginal product of what? Capital over the what? Over the rent. Are we together? So we now get to our output function. We're given LK the power half. So here we have what? Half labor, half capital. And somebody help us differentiate this. What is the derivative? What is the marginal product of labor here? Yes, Mr. Chimuka.
Meaning that we are differentiating L, then meaning that K will remain constant, then L multiply by 2.
Which is 1. Then what happens to the power for L?
The power for L will be -1, so meaning it will be half.
Good. Okay, Peggy, well, how do we find the marginal product of capital? Salome?
What we're going to do is we are going to differentiate capital. So it will be equal to K. It's going to be equal to K to the power -half.
We're differentiating with okay, K -half.
Yes. Then there we'll write L to the power half. L to the power half.
+half, correct.
Yes.
All right. So at this point, we now want to optimize. What is the optimization bundle? Marginal product of what? Labor over the wage must be equal to marginal product of capital over what? The rent. So what is the marginal product of labor? It's L with a -half, and capital has a +half. Then what is the marginal product of capital? It is L with a +half, capital with a -half. Then what was our wage? And what was our rent? So let's go back here. Our wage was what? 40. Our rent was 10. So rent is 10. And our wage is what? 40. Are we together so far? Then the guy with the negative will go down. So here, which one will go down? The L. So you're going to have 40 half. Down here, we're going to have 40 L half. Then here we have labor half. Then here we're going to have 10. Which one will go down? The K half. And cross multiply there. 40 times 1 is 40. L half times L half, it is L. 1 times 10 is 10. K half times K half is K. At this point, are we together? Are we getting this figure? Okay. Are we together? So in this case,
Yes.
we're going to simplify. We're going to have divide both sides by 10. So we're going to have what? 4L is equal to what? K. So this is our optimization function. So in this case, we now substitute this function into our cost function. So remember our cost function was what? So where there's K, we put 4L. So our cost function was what? Here. Where there's K, we put 4L. So this will be what? 80 is equal to 10 in brackets plus 40L. So we said where there is K, we're going to put what? 4L. So here we're going to have a 4L. So what are we going to have? 80 is equal to 40L plus 40L. So here we're going to have 80 is equal to what? 80L. So what becomes our L? Divide both sides by 8. So our L is what? 1. All right. Our K was equal to what? 4L. So where there's L, we're going to put a what? A 1. So K is equal to what? 4 times 1. So what becomes the value of our K? It will be a 4. So graphically, if you want to illustrate this, you understand this connotation to say constraint optimization will occur at a point when our capital, this is our output, 2LK to the power half. So since we found our K as 1 and our capital as 4, let's put L1 capital 4. If you're illustrating, although they're not always asked you to illustrate. So this is using the shortcut, which is optimization band. You can also use the long cut, which is the Lagrangian function, where you're going to have Q as a lambda, and here we have the cost minus rent for capital minus wages for labor. So in this case, we just expand 2L half, A half, and our lambda is simply the multiplier. The cost was what? 80. What was the value for rent? 10. So we're going to say 10K minus what? 40L. We're going to get the same answer though. So here, we're going to do the partial derivatives. The L over the labor. So where there is labor, that's where we're going to consider. So we can first expand this part here to L half. And here we have K half plus 80 lambda minus 10 lambda minus 10K lambda. Lambda K minus 40 lambda L. So I'm interested where there is L. So what is the partial derivative here? The K is what? Dummy. And here we're going to have L negative half. Here there is no L, it is 0. Here there is no L, it is 0. 40 lambda L, it is simply minus 40 lambda. So the first thing is we differentiate, then you equate to 0. This process, most students fear it because it's a little bit tedious. The one I showed you is just a shortcut. It is also acceptable. So I'm just trying to show you that we're going to get the same answer. Please follow through this very carefully. I expanded this in the pamphlet. So when you divide both sides by 40, our lambda here for the labor, I just noted them so that you understand it will be K to the power half, 40 L to the power half. So this is equation 1. I've just brought this L down because under indices, anything that is negative will go down there. So far, we're together?
Yes, sir.
All right. Then we go to the derivative in terms of what? K. So this expanded form, we're going to differentiate it in terms of what? K. So 2L half, K half plus 80 lambda minus 10 lambda L. This is lambda L, lambda K. 10 lambda K minus 40 lambda L. So now we're interested in the what? The lambda against the K. So here our dummy is L half. Half times 2 is 1. Half minus 1 is K negative half. Here there's no K, it's a 0. Here there's a K. So 10 lambda K is just minus 10 lambda. Here there's no K, so it's just considered as a constant. So when you get it to 0, we're going to simply have here L half over K half is equal to 10. Or maybe before I take it down, just for those that are not very good with math. So this one will be 10 lambda. So we divide both sides by 10. So we're dealing with the lambda for K. So here, our lambda for this K will therefore be L half over 10 K half. So this is the lambda for K. Then we also find the derivative of lambda. So we're going to differentiate this, the L over the lambda. We're simply going to get the budget line. Here, there is no lambda, it's 0. Here, there's no lambda, it's 0. So 80 lambda is 8. Negative 10K lambda is negative 10K. Negative 40 lambda K is negative what? 40L. So when we get this to 0, we just bring in these constants there. We're simply going to have 80 is equal to 10K plus 40 lambda, 40L. So this is just giving us a budget line. So now I'm interested in the lambda for K and the lambda for L. So the lambda for K is L half 10K half. So we just need to equate the lambda for K and the lambda for L. What is the lambda for K? L half over 10K half. And what was the lambda for L? Lambda for L, we found it as K half 40L half. So again, K half 40L half. K half 40K half. So we cross multiply 10K half times K half, this is 10K. L half times 40K half, this is simply 40K. When you divide both sides by 10, so this is 10K and this is 40L. Divide both sides by 10, so meaning our K is equal to 4L. So now after finding this, we now go back to our budget line. Our budget line is simply 80 is equal to what? 10K plus 40L. So where there's K, we'll put what? Our L 10 4L. So this will be 40L plus 40L, which will give us 80 is equal to 80L. So meaning our L is equal to 1. And when we put our 1 there, our K is equal to 4. So ultimately, we get the same answers, whether we're using the Lagrangian long formula or we're using our short formula that we understand. So whenever we are asked to maximize production, we maximize. If it's cost, we'll be taught to minimize. So let's look at an exam probable, which is given in this question.
Excuse me, sir.
All right.
Can you share the screen where we just equating the lambda for K and L? Is the replacement for lambda for L supposed to be K or L?
We're here.
No, above. Where it's
Lambda L and lambda K.
Now the lambda L.
So the lambda L, so here down, it's supposed to be L, yes. Thank you. Yeah.
Okay.
Thank you. All right, so any other questions? So you need to identify which one is your constraint. So we're going to look at this question. We're told that Ping Pong office furniture manufacturer over the North Gate of Lusaka zone has the following production function. So this is our production function. Suppose W is 50, R is what? 40. Determine the amount of labor and capital the firm should use in order to minimize costs of producing 1118 units of output. And what is the actual minimum cost? So here it's kind of the opposite. We're going to optimize in terms of our constraint, which in this case is production. So how do we minimize the costs? All right, so with our question here, let's come up with our constraint. So we're told that the production function is given by 100 L half K half. All right. And what else are we given? The wages are given as what? The wages here are given as wages is equal to $50. We're given our rent as $40. Okay. So we know cost is given by wages for labor and rent for capital. So this 118 is not the cost here, it's not a constraint. So we don't know this. It's a function that we want to minimize. So we're going to say 50 what? L plus what? 40K. The units are for the output. So we know that output is always in terms of what? The function, labor, and capital. So we're given the output 1118 units should be equal to our function of our output, which is 100K half and L half. So in this case, using the Lagrangian multiplier or Lagrangian function, we're going to minimize the cost. That's what we're being asked. Minimize the cost. So our function that will come here is what? 50L plus 40K. Okay, lambda. This one here, we just bring this on the side. That's how we minimize them. So here we're going to have 1118 minus what? 100K half. 0.5 is half. Sorry, when I say half, it's the same thing. Then K and L 0.5. So this is our optimization function to start with. Are we together so far before I proceed? So if we're given this amount in terms of kwacha or dollars, it would have come here on the cost, and this is what would have been minimizing the would have been maximizing the function of output. But in this case, we're minimizing cost. So the cost is our objective function. This one that comes here. So here we just bring this one there, just Q minus what? Our function in short in terms of labor and capital. So the units that we have here is 1118. Then the function is when it comes inside, you subtract. So 100 L half and K half. So let's do the partial derivatives. So here we have what? 50 L plus 40K plus lambda 1118 minus 100 L half and K half. So can somebody give me what is the partial derivative of a Lagrange in terms of labor? What do we have there? Who wants to try? Chimuka can start.
Here we have to differentiate the ones which have an L, the coefficients which have an L, then those without it will be eliminated from the equation.
Okay, so we can expand maybe to start with, so that we identify them that have an L, correct? So here, 1118, and here we have 100 lambda L 0.5, K 0.5. So our partial derivative of the labor, 50 L here gives us what? 50.
50.
And here it is 0. Here it is 0. Here we're going to have what? 0.5 times 100, we get a 50. Everything survives as it is because of their multiplying, but only the L is going to have a negative. All right. So when you get it to 0, we want to make lambda subject. So we're going to have 50 is equal to what? 50 L 0.5, K 0.5 lambda. So we divide both sides by this one, so I leave lambda alone. So here we're going to have 50 L, that is 0.5, then K 0.5. Okay, right here it cancels. So a lambda, therefore, this will cancel there. The only the negative, if it's a negative, it will go up. So we're simply going to have L 0.5 and here K 0.5. That is our lambda for the L. So the ladies help us differentiate in terms of capital using this function here. Let's find the derivatives.
It's going to be 40.
So it says 0. So here you're going to have what? 40, correct?
40.
Here is a 0
Then
again.
there to be 0. Yes.
And here,
And then there it's also going to be 0.
no, there's a K here. So
There it's going to be 0.5.
times 100, which is 50. Everything else will survive. The lambda will survive. The L 0.5 will survive. With the all multiply. But we subtract 1 from that one. So they have K negative 0.5. So when we get to 0, we're going to simply have 40 is equal to what? 50 L 0.5, K 0.5 negative, and our lambda this side. All right. Then we divide both sides by what we found here, 50 L 0.5, K 0.5 negative. So in this case, this cancels. So when you divide there, this will be 50 divided by 40 divided by 50, 0.8. Then which K will go on top? K, since there's a negative, K 0.5 to become a positive over L 0.5. So we have two lambdas we're equating now. The lambda for K and the lambda for L. Are we together so far? Like I want, this is the most delicate. So you need a lot of brainwork to understand. So how do we equate these two since they're both lambdas? Okay. So L 0.5. So lambda for L and lambda for K. So L 0.5, K 0.5. Then here 0.8, K 0.5, L 0.5. So cross multiply. So when we cross multiply, what are we getting? This by that, we're going to get L. This by that, we're going to get 0.8 K. So this is our function that we're going to now use in the equation. So what was our principal equation that we needed to substitute? So we're given this function here that we need to substitute. This one here. So since we have found what our L is 0.8K. So where there's L for 0.8K here. So we have 118, 100, K, 0.5. Then L is what? 0.8K. So here we're going to put 0.8K. All together so far? We'll multiply here. We're going to have 100 times 0.8, that's 8. Okay, K, you can add the indices there, there's a 1 there. So here we're going to have K 1.5. Okay. So 1118 divided by 80. We're going to have 13.975. This is K 1.5. So to find the value of K, we're going to square root this, or the easier one here is just power to 1 over 1.5 on each side over 1.5. So when you do that on both sides, you're going to find the value of K to be equivalent to 12.5. So K is 12.5. If I lost somebody, do I need to go through this again?
Yes, here when we are bringing the value of L there in the 118 equals to 100 K to the power 0.5, then L. L in brackets, it's to the power also 0.5. So I'm just lost there where.
So here
I only see
L is this times that one, it is L. K times that is a 1. So the 0.5 comes out. So we're just going to remain with what? 0.8. If you want to make K subject, you can divide both sides by 0.8. You can still have what? K is 1 over 0.8 L. So I said we're going to have our K is 1.25 K. Same thing, whatever you're making subject to a formula. Okay.
Yes, now when we substitute in the formula, is the 0.5 affecting the value of L in terms of, since we've said L is equals to 0.8 K. Since you have seen you put it in the bracket where you are substituting it, now I can see the 0.5 there multiplying by 0.8 to the power 0.5, then also L to the power 0.5.
Okay. At this point, do you understand this point here, first of all? How to get at this point?
Yes, where we have found L and the
all right.
Oh,
so
here you have
together
used the
so far at this
yes.
point.
Yes.
Let me go to the objective function. So our objective function was what? 118 is equal to what? 100 L 0.5 K 0.5. Here we understand, right? This is our objective function. Do we understand this one, right? Where it's coming from?
Yes, that one I understand.
All right. So we can now solve for either of them. If I substitute K, if I substitute L, either of them. Let me start with maybe L. So where there is L, where there is K, I put 1.25 K. Are we together?
Yes.
So here I'm going to have 118 is equal to 100. Okay. The L, we leave it 0.5. And the K is 1.25. Where there's K. So the question, your concern was why is the 0.5 coming going out? Okay. I guess, right?
Yes.
Actually, you're right. So this is the part there. Okay. So now 1118 we can distribute. So this is 100 L 0.5. This is 1.25 the power 0.5. And this is L the power 0.5. Are we together on this one now?
Yes.
Okay. So what is 0.25 to the power half?
That is 1.12.
1.118. Right?
Yes, 1.118. Yes, 1.118.
When we multiply by 100, what do we get?
That is 1.8.
1.1.8. Then this L half times L half is simply what? L, right?
Yeah, you add the power there.
Yes. 0.5 plus 0.8 is 1. When we divide here, 1.1.8, here 1.1.8. So our L becomes what? 10. So when we put this L in there, our K becomes what? 12.5. Are we together? Is that okay
So
now?
when we're looking for the value for K, it's supposed to be 1.25 L, right?
Yes, 1.25 L.
So can we, yeah.
So meaning the values of labor and capital are these ones here, 10 units of labor and 12.5 units of what? Capital. So the question further on went to ask, now, after finding the units of labor and capital that minimize cost.
Yeah, just there, sir, sorry.
Yeah.
Yeah, this one you brought in the Lagrangian. Can you use the same formula for finding marginal propensity for labor and marginal what marginal product for labor and marginal product for capital? It will give you the same answer.
Yes, it will give you some answer.
Okay. All right.
Yeah. Okay.
This one is quite complicated, I must confess.
Yes, it's quite complicated. So you need to have some background of some calculus for you to get the grip of this. I'm very
that one
happy.
sounds a bit fair.
Pardon?
That other one sounds a bit fair. The one for marginal product of labor.
Yeah, it sounds a little more fair. But usually sometimes lecturers want you to move step by step. So that one, I love it when I'm teaching people in a critical situation and they can't master this. But for you guys, I'm very confident that the way I broke it down, you're able to really go around it. Okay, having found the units of labor and capital, then they'll ask us to find the minimum cost. So cost we initially had was what? 50 what? L plus what? 40K. And now we can now substitute those figures there where there's 50. Where there's a L, we're going to put 10. Where there's 40, we're going to put what? 12.5. In this case, our minimum cost that we're going to have is going to be $1,000. This is our minimum cost. So this is a question I really wanted us to look at. It has seen a number of days, and please try it as your homework. Take your time. All right. Let's look at the second question here. Unless I've left anyone behind. In case you're behind, please.
Just for the sake of revision.
I think I have articulated that. So for us to answer quite a lot. So I broke it down. All these partial derivatives have been explained. And I found the values respectively and showed how we found this. So please go through this step by step. I only have a few minutes. I can go back again or do an alternative question. It's up to you. So under production, I think I itemized about 3 equations. So you can choose any one of these ones remaining. So which one do we look at? Question 2, question 3, or question 4? Or I can pick any.
Can we do 3?
And 3. Okay. So question 3 has given us an iso quant, which has combinations of inputs of 2 resources, X1 and X2, could be labor and capital. And those are 2 key resources. So we want to calculate which combination meets the least objective when the prices of the factors are given. So we'll come up with a table with the specific prices of price of X1 and price of X2 for part A, X1 and X2 for part B. Then we are going to get the optimum bundle computation. So here we are. And just go to the pamphlet quickly. You can easily. So I'm going to have the values of X1 from 39 up to 0 here, and values of X2, 0, 1, 2, up to 25. Then we'll find the changes in each of them. So change for this is labor or X1 input. We're just dividing this divided by that, this minus that. So 28 minus 39 is negative 11. 20 minus 28 is negative 8. 14 minus 20 is negative 6. 9 minus 14, negative 5. 5 minus 9, negative 4. 1 minus 5, negative 4. 0 minus 1 is negative 1. So this is how we're getting the changes. Then we go to input 2. The first one is a dash because it doesn't have members of the dash. So 1 minus 0 is 1. 3 minus 1 is 2. 5 minus 3 is 2. 8 minus 5 is 3. 12 minus 8, 4. 17 minus 12, 5. And 25 minus 17 is 8. So we're going to now divide the change of input X1 divided by change in input of X2. So 11 over 1 is negative 11. 8 over 2 is negative 4. Negative 6 over 2 is negative 3. 5 over 3 is negative 1.6. 4 over negative 4 over 4 is negative 1. Negative 4 over 5 is negative 0.8. And negative 1 over 8 is 0.13. So we've been given the price combination for part A. So our key thing here is to compare the changes. They must be equal for them to be optimal. So price for X2 divided by X1 must be equal to change in X2, change in X1 over, it's like they are in an opposite. So X1, so change in X1 over change in X2. If you want alternatively, of course, that's the easiest because of the format that I've used there. But if you want alternatively, you can just put the change in X1 over price of 2 and change in X2 over price of 1. It's the same thing. But then following what we've done here, get me closely. Don't interchange them. Change in X1 over change in X2 should be equal to the price X2 over price X1. So here, the first combination was what? 11. So you need to look at which combination will equate to what we found there. So we have the price. We call that the marginal rate of technical substitution, MRTS. So whatever will be equal to the figure we're going to get is the optimal combination. So price of X2 is 6.40 and price of X1 is 8. So we divide 6.40 divided by 8, we get negative 0.8. So when we're going to check in here, we're going to find negative 0.8 on combination 7. So we're going to say the combination that meets objective 1 occurs at what? Combination 7, where we have X1 as 1 and X2 as what? As 17. So you can simply mention combination 7. Is that clear?
Just quickly run through it again.
So given
After
the values of input X1 and input X2, the way we found the marginal rate, we just divide our differences, the changes. So in here, for this figure here, the first one is a dash, so do 28 minus 39 is -1. Okay, 20 minus 28 is -8.
That is
so
fine.
You do that.
That is fine. You can start from
Then
where
you
we are
also
finding
go
the
here,
combination.
we divide each of these ones, you get the differences there up until the end. Then after that, you now divide this one divided by that, -11. 8 divided by 2, -4. 6 divided by 2, -3. 5 divided by, we get these figures here. So we're just dividing change in x1 over change in x2. So these are the values there. Now, we've been given the price of what? Good. Price of input 2 and price of input 1. So don't interchange them. So the change in x1 over change in x2 must be equal to the price of x2 over price of what? x1. So key is now comparing the value we're going to get here. So the price of x2 is 6.4. So here they should be negative. The formula comes to the negative because it's an inverse relationship. Divided by 8.0. So when you divide this in there, we're going to get negative 0.8. So this 0.8 now you compare it here. Which figure is equal to 0.8? So when you go into this table, 0.8 is here. So which combination is equal to that figure? Combination 7, or specifically where x1 is equal to 1 or x2 is 17. So this is a combination that is optimal, because optimal combination must fulfill this what? Rule. Is that clear now?
Very clear, thank you.
So you do the same for part B, where you are now going to redo the formula. You can leave the same table as it is, but here you're going to divide 0.75 over 0.25. When you divide those two, 0.75 over 0.25, we're going to get negative 0.3 or negative 3. When you go in here, you find the figure which is equivalent to negative 3. It is here. So I mean the combination that is optimal at those prices is what? 4, where x1 is 14 and x2 is 5. So is that clear? You don't need to redraw this table, it's already there. So the combination has been given. Are we together? Are we all together?
Yes.
All right. So part B, given the production output, which is given by this, the price of Y is 5 kwacha, price of X is 8 kwacha. We are asked that relate costs to output and derive the total cost, marginal cost, and our average cost function. So this is just on calculus. We want to derive the functions. So we know that total revenue is equal to what? Price times quantity. All right. So in this case, we've been given the function in terms of Y. So let me take my time. People lost 10 marks here. So we're given the function of production as Y is equal to 2x squared. The price of X was given as 8 kwacha. The price of Y was given as 5 kwacha. So we're being asked to find or derive in terms of those ones, the total cost, to derive the marginal cost, to also derive our average cost. Find total cost, find average cost, find marginal cost. So here we've been given the key that this is a production function which relates to cost in terms of Y. So now, what must we be cognizant of? What must we be cognizant of? That cost function is given in terms of px and x. So cost function here is a function of y. And we've been told that y is what? 2x squared. So we know that total cost is given by what? Fixed cost, as we know, plus variable cost, you can say. So the price of x times x will give us a cost function. So here, total cost, price of x times x. So with the parameters that have been given here, total cost will therefore be equal to 8x. Now, we know that to find average cost, who remembers the formula? Is simply total cost over what? Quantity. To find marginal cost, it's simply the TC over TQ. Okay. So you remember this from our class that we had in pre-math. Are we together so far? Before I proceed, are we together so far? Okay. So whether we're together or not, let me proceed so that I prepare for another class. So we're now going to derive the total cost in terms of okay, so we want to derive the total cost. So we've been given that y is equal to 2x squared. So we can make x subject because that's our critical function in terms of the cost. So if we make x subject, we divide both sides by 2. So y over 2 is equal to x squared. So if we make x subject, we're going to square root on both sides. So meaning our x will be y over 2 root. So we computed our total cost as px times x. And remember, our total cost was what? 8x. So we're now going to substitute x, since we found the value of x, where there's x, we're going to put what? Square root of y over 2. So this will now give us whenever we're square rooting anything, it's as good as the power half if you want. Okay. So are we together so far?
Yes, sir.
So if you want, you can expand this total cost. You want to make y subject for me. So it's the same as what? Root y over root 2. So we're going to divide, what is 8 divided by square root of 2? 8 divided by square root of 2. 5.65. Then anything square root is the same as the power half. Okay. So this is a function of the total cost arising from that. Now, after finding our total cost, now we can safely find our marginal cost by differentiating this. So marginal cost in this case would be dTc over dy. So it's simply going to multiply half times 5.625. It will give us 2.828. Then subtract 1 from the half, will give us negative what? Half. So that becomes our marginal cost. If you want to be a power positive index, we're going to have 2.828 divided by y to the power half. That is how we find our marginal cost in terms of y. Then how do we find our average cost? Average total cost is simply the total cost over quantity, and our quantity in this case is in terms of y itself. So we're going to divide our total cost, which we have here, 5.65 y to the power half, divided by the quantity that we have, which is y. So average total cost, and divide that. These indices are subtracting. So we're going to subtract half minus 1. So the final answer here will simply be 5.65. Then we have half minus 1, which is negative half. This is how we find our average total cost. So this is where the 10 marks were coming from. It's a very tricky question that you need to revisit. Please, in case you are stuck, go through my pamphlet and it will unlock everything. These questions are repetitive.